Impact of a primary sedimentation tank on wastewater treatment plant units using computer simulation program. The purpose of wastewater treatment is to prepare controlled conditions with comparatively small size to remove suspended and soluble materials. The primary sedimentation tank certainly has a great effect on biological treatment. The sedimentation tank facility reduces the organic load that will be processed in the biological unit earlier. The typical and standard wastewater treatment plant consists of a series of steps or units processed tied together with the ultimate purpose of taking the raw sewage effluent and turning it into an effluent that's often several times cleaner than the water in the outfall water body. A typical wastewater treatment plant is accomplished by general steps which are shown in figure 1. This figure shows a typical wastewater treatment plant unit. The research objectives is the first objective of this research is to investigate the effect of presence or absence of primary sedimentation tank on other wastewater treatment plant units. And second is to find out if there is an amount of discharge and or biological load after which it is more convenient to use primary sedimentation tank by designing a typical wastewater treatment plant with different discharges and biological loads with the aid of a computer program that will be written in Visual Basic. The computer program in this study was built to design wastewater treatment plant with two cases. First case is the design of treatment plant in the presence of a sedimentation tank, while the second case is design in absence of sedimentation tank. A sample of program main windows are shown in figure 2 and figure 3. A verification of computer program usually is checked by a formula or standard equation. In the absence of such equations, the program is to be checked with data that has been determined by hand calculations. The results obtained from verifications are accepted as the program results shows good convergence with that obtained by hand calculations as shown in figures 4 and 5 as an example. The data that was used in the present study obtains the values and the characteristics of sewage that is used are showed in table 1. The analysis that have been done, single regression models and type forms are used, each one of design requirements to investigate which form gives the best fitting of data. Also, cost analysis is done by using the program to calculate the volumes of wastewater treatment plant units in two cases. The first case in the presence of sedimentation tank, and the second case in the absence of sedimentation tank, primary sedimentation tank. The construction cost of each unit for activated sludge treatment plants used in the present study are shown. Two, the results. This table shows the radiation basin volume data fit, which shows a good convergence with R-square of 0.997. The cost analysis models also have been made. For example, this figure 7 shows an example of cost analysis. Conclusions. Present study has come out with the following main conclusions. The volume of a radiation basin and secondary sedimentation tank increase if primary sedimentation tank is to be omitted from the design of the wastewater treatments. This increment is dependent on influent and effluent characteristics. Generally, we can say that an increment of about 52 to 170% of aeration basin and 58 to 185% of secondary sedimentation tank were observed in the present study. Second, the volume of each sludge treatment unit decreased when primary sedimentation tank is neglected in design. The amount of decrease is also depending on the characteristics of effluent and influent. Approximately, gravity thickener volume is decreased about 29 to 42%, and aerobic digester volume is decreased by 38 to 52, and dying beds were decreased by 29 to 38%. Also, it's more convenient, the third conclusion, more convenient to and economic to use a primary sedimentation tank when the effluent is above 306,708.33 cubic meter per day, when the waste is sludgy from aeration basin, and 24,833.33 cubic meter per day if the waste is sludgy from secondary clarifier. Thank you for your attention.